Close your eyes for a second and imagine you're drifting. No weight, no noise, just the soft, velvet embrace of the void. We often think of our solar system as a series of static drawings in a textbook, but the reality? It's a chaotic, beautiful, and sometimes terrifying masterpiece of physics. We're talking about worlds where it literally rains diamonds from a pitch-black sky, and moons that hide vast, salt-heavy oceans beneath miles of bone-chilling ice. There's a volcano on Mars 3 times the height of Everest, standing in total silence, and a storm on Saturn shaped like a perfect, haunting hexagon. Tonight, we aren't just looking at planets. We're stepping into the stories they tell, stories written in magnetic storms and ancient sunlight. From the screaming supersonic winds of Neptune to the ghostly, disappearing rings of Saturn, we're embarking on a journey to the very edge of the sun's reach. Are you ready to see home in a way you've never seen it before? Before we break orbit, I'd love to know, where in the world are you watching from tonight? Drop your city or country in the comments. It's always incredible to see how far our community reaches. And if you're a fan of these deep space deep dives, go ahead and hit that like button and subscribe. It really helps the channel grow, one curious soul at a time. Now, let's begin. To understand the scale of our solar system, we have to start at the edge at the cobalt blue mystery known as Neptune. Imagine a world so far away that the sun is nothing more than a particularly bright star in a permanent twilight sky. It's cold here, a kind of cold that doesn't just freeze water. It freezes the very concept of movement. Yet, paradoxically, Neptune is the most violent place in our neighborhood when it comes to weather. While we complain about a gust of wind at 50 miles per hour on Earth, Neptune laughs in supersonic. Winds here whip through the upper atmosphere at speeds exceeding 1,200 miles per hour. That is faster than the speed of sound. If you were standing there, provided you hadn't been instantly turned into a human popsicle, the sound of the wind wouldn't even reach your ears before the air itself slammed into you. It's a strange, lonely ferocity. Because Neptune is a gas giant, there's no solid ground to slow these winds down. There are no mountain ranges to break the flow, no forest to friction away the energy. It is a pure, unadulterated race of frozen gases circling a world that shouldn't, by all logic of solar heating, have that much energy. But what makes Neptune truly poetic isn't just its weather. It's how we found it. Neptune wasn't discovered by a lucky astronomer pointing a lens at the right patch of dark. It was discovered with a pencil and a piece of paper. In the mid-1800s, astronomers noticed something wrong with the orbit of Uranus. It wasn't following the path that Newton's laws predicted. It was being tugged, slightly but surely, by an invisible ghost. 2 mathematicians, Urbain Le Verrier and John Couch Adams, sat down and did the math. They calculated exactly where an 8th planet would have to be to exert that kind of gravitational pull. When Johann Gottfried Galle finally turned his telescope to the coordinates Le Verrier provided, Neptune was right there within 1 degree of the prediction. It was the ultimate triumph of human logic over the vastness of the dark. We knew it was there before we ever saw it. Think about that for a second. We live in a universe so consistent, so bound by the laws of physics, that we can feel the heartbeat of a planet billions of miles away just by watching its neighbor stumble. Neptune is a testament to the fact that in space, nothing happens in isolation. Everything is pulling on everything else. If you were to dive deeper into those blue clouds, past the supersonic winds, you'd encounter an environment that defies everything we know about weather on Earth. Neptune's deep blue color comes from methane in its atmosphere, which absorbs red light and reflects back that haunting, oceanic hue. But beneath that serene exterior lies a pressure cooker of cosmic proportions. Scientists believe that deep within the mantles of Neptune and its cousin, Uranus, the pressure is so intense that it can literally crush carbon atoms into diamonds. Imagine that for a moment. Deep in the dark, where no human eye will ever see, it is likely raining solid diamonds. These glittering stones would sink through the slushy layers of icy water and ammonia like hail in a slow-motion storm, eventually collecting in a thick layer around the planet's core. It's a world made of precious stones and liquid metal, wrapped in a blanket of freezing gas. But Neptune isn't just a solitary giant. It has a family of moons that are just as strange. The most famous is Triton. Triton is a bit of a rebel. It's the only large moon in the solar system that orbits in the opposite direction of its planet's rotation. This retrograde orbit is a huge red flag to astronomers. It tells us that Triton didn't grow up with Neptune. Instead, it was likely a wandering world from the Kuiper Belt, a stray traveler that got too close and was snatched up by Neptune's massive gravity billions of years ago. Triton is also one of the few places in the solar system where we've seen active geological life. It has volcanoes that don't erupt with molten rock, but with a freezing mixture of liquid nitrogen, dust, and methane. When the sun's faint heat hits the dark patches on Triton's surface, it turns the nitrogen ice underneath into gas, which then erupts in plumes that can reach 5 miles high into the thin atmosphere. As we leave Neptune and begin our journey inward, we realize that this planet is a guardian of the outer dark. It's a reminder that the further we go from the fire of the sun, the more the laws of nature seem to twist into something from a dream. Neptune is cold, it is violent, and it is hidden, but it is also a place where it rains diamonds and where the wind travels faster than a jet fighter. As we leave the freezing, supersonic whispers of Neptune behind and move inward, the landscape shifts from deep blue gas to a world of rusted iron and silent giants. Mars. It's a planet that has captivated us for centuries, not just because it might have once held life, but because its geology is written in superlatives. Everything here is bigger, deeper, and more dramatic than anything we have on Earth. Imagine standing on the edge of a cliff so high that the bottom is lost in a reddish haze. You are looking at Valles Marineris, the Grand Canyon of Mars, but calling it a Grand Canyon is like calling the Pacific Ocean a pond. This system of canyons stretches more than 4,000 kilometers across the Martian equator. If you placed it on Earth, it would span the entire width of the continental United States from New York to Los Angeles. In some places, it plunges over 7 kilometers deep. That's more than 5 times the depth of our own Grand Canyon. But the real mystery is how it got there. On Earth, canyons are usually the slow work of water rivers like the Colorado, patiently carving through rock over millions of years. Mars, however, tells a more violent story. Scientists believe Valles Marineris isn't a riverbed, but a tectonic scar. Billions of years ago, as the planet's crust was pulled apart by volcanic activity in the nearby Tharsis region, the ground literally cracked open. It's a frozen moment of planetary trauma, a reminder that Mars was once a world of shifting plates and rising magma before it grew quiet and cold. And then, there are the storms. On Earth, a dust storm might ruin your afternoon. On Mars, they can swallow the entire planet. Because the dust is incredibly fine, it can stay suspended in the thin atmosphere for months, turning the sky into a hazy reddish glow and blocking out the sun entirely. In 2018, one of these global tempests was so thick it actually ended the mission of the Opportunity rover by choking its solar panels. It's a restless desert world where the wind still shapes the land, even in the absence of rain. If Valles Marineris is the deepest scar on the face of Mars, then Olympus Mons is its greatest crown. To truly grasp the scale of this mountain, you have to throw away everything you know about mountains on Earth. Olympus Mons is a shield volcano, and it is the largest volcano and the tallest mountain in the entire solar system. Standing at a staggering 21 kilometers high, it is nearly 3 times the height of Mount Everest. But it's not just the height, it's the sheer bulk. This volcano is about the size of the state of Arizona or the entire country of Poland. Because Mars is a smaller planet with much lower gravity, the crust could support much more weight before buckling. On Earth, a mountain this size would literally sink into the mantle. But why did it get so big? On Earth, our tectonic plates are constantly moving. When a volcano forms over a hot spot in the mantle, the plate eventually slides away, and the volcano goes extinct while a new one forms next to it. This is how the Hawaiian Islands were made. But on Mars, the plates don't move. The crust stayed perfectly still over a massive plume of magma for billions of years, allowing Olympus Mons to just keep growing and growing, layer by layer of cooling lava until it reached the very edge of space. In fact, if you stood at the summit, you wouldn't feel like you were on a mountain at all. The slope is so gentle and the mountain so wide that the curve of the horizon would actually hide the base of the mountain from your view. You would simply feel like you were standing on a high alien plateau, looking out into the thin black atmosphere. As we look at these features, the massive canyon and the towering volcano, we see a planet that was once incredibly active. Mars was a world of fire and movement. But today, it is a silent graveyard of giants. The core cooled, the magnetic field faded, and the atmosphere was slowly stripped away by the solar wind. Yet, there is a quiet beauty in its stillness. It's a place where the footprints we leave tomorrow might remain undisturbed for millions of years, preserved in the red dust of a world that refused to do anything small. If Mars is a world that died of cold and neglect, our next stop is a world that died of a fever, Venus, often called Earth's sister planet. Because of its similar size and composition, that's where the family resemblance ends. Venus is quite literally the most inhospitable place in the solar system, a victim of a greenhouse effect that ran completely off the rails. While Mercury is closer to the Sun, Venus is actually hotter. It's a thick, choking blanket of carbon dioxide that traps every bit of solar heat, pushing surface temperatures to a constant 900 degrees Fahrenheit. That is hot enough to melt lead. If you were to stand on the surface, ignoring the fact that the atmospheric pressure would crush you, instantly like an empty soda can, you would be standing in a yellowish, dim twilight. The clouds are so thick that the sun never actually peeks through. It's just a heavy, oppressive glow. And those clouds? They aren't made of water vapor. They are made of sulfuric acid. It rains acid on Venus, though the heat is so intense that the droplets evaporate before they ever hit the ground. But the real oddity of Venus is its movement. Almost every planet in our solar system rotates in the same direction counterclockwise. Venus, however, is the rebel. It rotates clockwise. This is known as retrograde rotation. Even stranger, it rotates so slowly that a day on Venus, one full spin, actually lasts longer than a year on Venus, one trip around the Sun. You could literally walk faster than the planet rotates. Why does it do this? Many scientists believe that eons ago, Venus was struck by a massive object, perhaps a protoplanet that was so powerful it literally knocked the planet off its feet or flipped it upside down. It's a planet that seems to have been broken by its own history, a world where time and direction have lost their meaning. One of the most tragic things about Venus is what it lacks: a magnetic field. On Earth, our liquid iron core acts like a giant dynamo, spinning and generating a protective magnetic shield that deflects the sun's harsh solar wind. Venus, despite having a similar core, doesn't have this protection. Some scientists think this is because its slow rotation isn't enough to get that dynamo effect moving. Without a shield, the sun's radiation has spent billions of years stripping away the lighter elements of the Venusian atmosphere, specifically hydrogen. When you lose hydrogen, you lose water. It's believed that billions of years ago, Venus might have had shallow oceans and a climate much more like our own. But as the sun grew hotter, the oceans evaporated. The water vapor, a potent greenhouse gas, trapped even more heat, which caused more evaporation in a feedback loop from hell. Eventually, the solar wind carried the water into space, leaving behind a dry, baked husk of a planet. It is a cautionary tale written in the stars, a glimpse of what happens when a planetary thermostat breaks. But Venus still has secrets. While the surface is a nightmare, about 30 miles up in the atmosphere, the temperature and pressure are surprisingly similar to Earth. There have even been whispers of phosphine, gas detected in those clouds, a chemical that on Earth is often linked to microbial life. Could life have retreated from the scorching surface to find a home in the acidic clouds? It sounds like science fiction, but Venus has a way of defying expectations. As we pull away from the yellow haze of Venus, we see a planet that is both a twin and a monster. It reminds us that habitability is a fragile, precious balance. It's a world of crushed metal, acid rain, and a sun that rises in the west and sets in the east. It is the brightest object in our night sky, a morning star that hides a furnace within. As we travel further back into the outer reaches of the solar system, we encounter a world that is fundamentally wrong by every standard of planetary physics, Uranus. To the naked eye, it's a pale, featureless cyan ball looking almost like a billiard ball suspended in the dark. But Uranus is a world defined by a cosmic accident so massive it changed the planet's destiny forever. Unlike every other planet in our solar system, which spins more or less like a top, Uranus spins on its side. Its north and south poles are located where most planets have their equators. Imagine a world where the sun doesn't rise and set every few hours, but instead, one pole faces the sun directly for 42 years at a time, followed by 42 years of total, soul-chilling darkness. It's as if the planet was simply knocked over. The leading theory is that during the early, chaotic days of the solar system's formation, a protoplanet roughly the size of Earth slammed into Uranus. This impact was so violent it didn't just tilt the planet. It effectively broke its internal heat engine. While its neighbor Neptune radiates a significant amount of internal heat, Uranus is strangely quiet. It is the coldest planet in the solar system, even colder than Neptune. Despite being billions of miles closer to the Sun, this extreme cold creates a unique chemistry. Uranus isn't just a gas giant. It's an ice giant. Its atmosphere is a thick soup of water, methane, and ammonia ices. Because of the way methane absorbs red light, we see that soft, ghostly blue-green. But the real magic happens deeper down, where the atmosphere transitions into a hot, dense fluid. In the crushing depths of Uranus, the chemistry becomes something truly cinematic. Because the planet is rich in methane, a molecule made of carbon and hydrogen, the intense pressure and heat deep within the mantle do something extraordinary. They squeeze the methane until the carbon atoms break free and crystallize. Scientists believe that it literally rains diamonds inside Uranus. These aren't the tiny specks you'd find in a ring. They are likely massive, glittering chunks of solid carbon sinking through a sea of liquid metallic ammonia like slow-motion hail. There is even a theory that deep enough down, there could be literal oceans of liquid diamond with diamond bergs floating on the surface. It is a world where the most precious treasures on Earth are simply common weather. But the oddities don't stop at the rain. Uranus has a magnetic field that is completely broken. On most planets, the magnetic field is aligned roughly with the axis of rotation like a bar magnet stuck through the center. On Uranus, the magnetic field is tilted 59 degrees away from the axis and is offset from the planet's center by about a third of the planet's radius. This creates a wobbly, corkscrew-shaped magnetosphere that tumbles through space as the planet rolls on its side. It's messy, it's chaotic, and it's unlike anything else we've seen. This erratic field might be caused by the movement of a salty, conductive superpressurized water ocean deep inside the planet, rather than a molten metal core. As we move away from Uranus, we leave behind a world that feels like an outlier, a planet that was knocked down but kept spinning, a world of pale blue silence that hides a heart of diamonds and a chaotic magnetic soul. It serves as a reminder that the further we go, the less the universe cares about our standard rules of how a planet should behave. After traveling through the freezing winds of Neptune and the acid fogs of Venus, we finally return to a marble of sapphire and white, Earth. But when we look at our home through a cosmic lens, it stops being just the ground beneath our feet and starts looking like one of the most complex machines in the known universe. One of the most profound things about Earth is its density. You might think the giant gas planets would be heavy because of their size, but Earth is actually the densest major planet in the solar system. We are a compact, heavy ball of iron, nickel, and rock. This density is the engine of our world. Deep beneath us, the core is still screamingly hot, nearly as hot as the surface of the sun. This heat doesn't just stay trapped. It moves. It creates convection currents in the mantle that slowly, agonizingly push the continents around. This process, plate tectonics, is something we haven't confirmed on any other planet. Earth is alive in a geological sense. While Mars grew cold and still, and Venus became a stagnant furnace, Earth's surface is constantly being recycled. Mountains are pushed up, seafloors are pulled down, and carbon is buried and then released through volcanoes. This isn't just a geological quirk, it's a global thermostat. Plate tectonics helps regulate our temperature over millions of years, keeping the planet from freezing over or boiling away. And then there is our moon. Most planets have moons, but ours is special. Compared to the size of its host planet, the moon is massive. It's so large that Earth and the moon are often described as a double planet system. Without that giant gray rock hanging in the sky, life as we know it might not exist. The moon's gravity acts like a stabilizer. Think of Earth like a spinning top. Without the moon, the Earth would wobble wildly on its axis over thousands of years. This would cause the climate to swing chaotically. The North Pole might find itself facing the sun, then swinging back into total darkness. The moon's gravitational tug keeps our tilt steady at about 23.5 degrees, giving us the predictable seasons that allowed complex life to flourish and plan for the future. Beyond the shifting plates and the stabilizing pull of the moon, Earth possesses an invisible suit of armor that most of us take for granted every single day. This is our magnetosphere. Because Earth has a massive swirling core of liquid iron and nickel, it acts like a colossal bar magnet. This creates a magnetic field that stretches thousands of miles into space, forming a teardrop-shaped shield. Without this shield, the sun's solar wind, a constant stream of high-energy particles, would have stripped away our atmosphere eons ago, just as it did to Mars. Instead, these particles are deflected. Sometimes they get caught and channeled toward the poles, where they slam into our atmosphere and create the shimmering, ghostly curtains of light we call the aurora borealis and aurora australis. When you see those lights, you aren't just seeing a pretty show. You are witnessing our planet's shield in active combat, protecting every living thing on the surface from cosmic radiation. Then there is the Goldilocks factor. Earth sits in a very specific region around the sun called the habitable zone. We are just far enough away that our water doesn't boil off into steam, and just close enough that it doesn't permanently freeze into solid ice. We are the only place we know of where water exists in all three states: liquid, solid, and gas. This water cycle is the planet's circulatory system, moving energy and nutrients around the globe. It's easy to feel small when looking at the gas giants, but Earth is a powerhouse of precision. We have a moon that steadies our stride, a core that generates a shield, and a crust that recycles the very air we breathe. We aren't just a rock floating in space, we are a complex, self-regulating spacecraft. As we prepare to leave home again and head toward the gas giants' moons, remember, everything we see out there only highlights how rare and miraculous it is right here. If there is one thing we've learned from exploring our cosmic backyard, it's that looks can be incredibly deceiving. For a long time, We thought the habitable zone, that perfect distance from the sun where liquid water can exist, was the only place to look for life. But as we move toward the outer solar system, we've discovered that heat doesn't just come from the sun. It can come from within. Take Europa, one of Jupiter's largest moons. From the outside, it looks like a cracked billiard ball, a world of blinding white ice crisscrossed by reddish, vein-like streaks. It is one of the smoothest objects in the solar system because it has almost no craters. Why? Because the ice is constantly renewing itself. Beneath that 10 to 15 mile thick shell of ice, scientists are almost certain there lies a global, salty ocean containing more than twice the amount of water found in all of Earth's oceans combined. This ocean stays liquid not because of sunlight, but because of tidal heating. As Europa orbits the massive Jupiter, the planet's immense gravity pulls and stretches the moon. This creates internal friction, which generates heat enough to keep an entire hidden world liquid in the freezing depths of space. Imagine a dark, silent sea that hasn't seen the sun in billions of years. On Earth, we find life at the bottom of our own oceans near hydrothermal vents where chemical energy replaces sunlight. Could the same be happening on Europa? It is perhaps the most tantalizing maybe in the search for extraterrestrial life. Leaving the warm, dark depths of Europa, we travel billions of miles further out, past the gas giants, to a place where the sun is just a pinprick of light. Here, we find Pluto. For decades, we thought Pluto was just a dead, frozen rock, a lonely sentinel at the edge of the system. But when the New Horizons spacecraft flew past it in 2015, we were stunned by what we saw. Pluto has a heart. Formerly known as Tombaugh Regio, this massive heart-shaped glacier is made of nitrogen ice. But the most shocking part? The left lobe of the heart, a vast plain called Sputnik Planitia, is completely smooth. In the world of planetary science, smooth means young. There are no craters there because the surface is being constantly refreshed. This suggests that even out here, where temperatures hover around -400 degrees Fahrenheit, Pluto is geologically active. Some scientists believe that, much like Europa, Pluto might hide a liquid ocean deep beneath its nitrogen ice. If Pluto, tiny, distant, frozen Pluto, has enough internal heat to keep an ocean liquid, it changes everything we thought we knew about where life could survive. It means the habitable zone isn't a thin ring around the sun. It's a series of pockets scattered throughout the entire galaxy. But Pluto isn't alone. It has a moon, Karen, that is so large compared to Pluto itself that the two of them actually orbit a common point in space between them. They are locked in a cosmic dance, always facing each other, like two dancers holding hands and spinning in the dark. As we drift away from Pluto and back into the void, we realize that the outer solar system isn't a graveyard. It's a collection of hidden worlds, each with its own rhythm, its own heat, and its own secrets. From the deep salt seas of Europa to the nitrogen glaciers of Pluto, the ice of the solar system is where the most exciting stories are being written. If there is one image that defines the beauty of our solar system, it is the profile of Saturn. It is the crown jewel, a gas giant so light that if you could find a bathtub big enough, the entire planet would float on water. But while the planet itself is a golden-hued marvel of hydrogen and helium, it's the rings that steal the show. Up close, these rings aren't the solid, flat disks they appear to be from Earth. They are a chaotic, shimmering debris field made of billions of individual pieces of ice and rock. Some are as small as a grain of sand. Others are as large as a mountain. They are incredibly wide, stretching out over 175,000 miles from the planet, but they are razor thin, averaging only about 30 feet in thickness. To put that in perspective, if you had a model of Saturn the size of a frisbee, the rings would be thousands of times thinner than a human hair. But there is a melancholy truth to this beauty. The rings are disappearing. Astronomers call it ring rain. Saturn's intense magnetic field is pulling the icy particles down into the planet's atmosphere, where they vaporize. We are living in a tiny lucky window of cosmic time. The rings likely didn't exist when the dinosaurs roamed the Earth, and in another 100 million years, they will be gone. We are witnessing a fleeting masterpiece. Beyond the rings, Saturn hosts a world that is perhaps the most Earth-like place in the solar system, though in the strangest way possible. Titan, Saturn's largest moon, is the only moon with a thick, substantial atmosphere. It has weather, clouds, and rain, but on Titan, it's too cold for water. Instead, it rains liquid methane and ethane. There are vast, dark lakes of liquid natural gas on its surface, and even sand dunes made of frozen hydrocarbons. It is a world where the chemistry of life is present, but the temperature is turned down to a haunting minus 290 degrees Fahrenheit. While the rings and Titan often steal the spotlight, Saturn hides a mystery at its north pole that looks like it was designed by a geometer rather than nature. It is the Great Hexagon, a six-sided jet stream wider than 2 Earths. Unlike the circular hurricanes we see on our own planet, this storm maintains a perfect, rigid geometric shape as it rotates. Scientists have struggled for years to explain it, but it seems to be a result of the way different wind speeds interact in the deep atmosphere. At the very center of this hexagon is a massive, swirling vortex, a polar eye that looks like a gateway into the planet's dark interior. But if you're looking for the most active place in the Saturnian system, you have to look at the tiny, brilliant white moon called Enceladus. It is the most reflective object in the solar system, looking like a fresh snowball suspended in space. But Enceladus isn't just a quiet ball of ice. At its south pole, there are deep cracks known as tiger stripes that are actively screaming. These cracks blast giant plumes of water vapor and ice grains hundreds of miles into space. These geysers are so powerful that they actually create one of Saturn's outer rings, the E-ring. When the Cassini spacecraft flew through these plumes, it detected organic molecules and salts. This suggests that beneath the ice of Enceladus lies a warm, salty ocean with hydrothermal vents on the seafloor, almost identical to the environments where life is thought to have started on Earth. It is a tiny moon, but it might be the loudest voice in the solar system calling out that we are not alone. As we leave Saturn, the image of those vanishing rings stays with us. It's a reminder that nothing in the universe is permanent. Even the most majestic structures are just passing through, leaving behind a trail of ice and mystery for us to find. Now we approach the king. Jupiter is not just a planet. It is a failed star, a massive ball of gas so large that it could fit all the other planets in the solar system inside it twice over. It is the vacuum cleaner of our neighborhood, its massive gravity pulling in stray comets and asteroids that might otherwise threaten Earth. But to get close to Jupiter is to dance with a monster. The most striking feature is, of course, the Great Red Spot. It's a hurricane that has been screaming for at least 300 years and likely much longer. It is wider than our entire planet, with winds at its edges reaching 270 miles per hour. But Jupiter's power isn't just in its winds. It's in its invisible environment. Because of its rapid rotation and metallic hydrogen interior, Jupiter has a magnetic field 14 times stronger than Earth's. This field creates a radiation belt so intense that it would fry the electronics of a standard spacecraft in minutes. It is a beautiful, swirling death trap. Yet, in the middle of this radiation, we find the most geologically tortured world in the solar system, the moon Io. If you were to look at Io, you might think it looks like a giant, moldy pizza covered in yellows, greens, and oranges. But those colors are actually deposits of sulfur from hundreds of active volcanoes. Io is caught in a gravitational tug-of-war between the massive Jupiter and the neighboring moons, Europa and Ganymede. This constant stretching and squeezing creates so much internal friction that the moon's interior is almost entirely molten. It is the most volcanic place in the solar system, with plumes of sulfur shooting 300 miles into the sky. It is a world of fire and brimstone, orbiting a planet of liquid metal and thunder. If Io is the fire of the Jupiter system, then Ganymede is its iron heart. Ganymede is not just a moon, it is a titan. It is the largest moon in the entire solar system, so large in fact that it is actually bigger than the planet Mercury. If it weren't orbiting Jupiter, we would almost certainly classify it as a planet in its own right. But what makes Ganymede truly unique is something it shares with Earth. It has its own internally generated magnetic field. It is the only moon we know of that possesses one. This means that Ganymede has a liquid iron core that is still spinning, creating a bubble of protection within Jupiter's much larger magnetosphere. It's a world within a world, a moon that acts like a planet, hiding a massive saltwater ocean deep beneath its icy crust, an ocean that might contain more water than all of Earth's surface water combined. However, the most human thing about Jupiter isn't something we can see, but something we can almost hear. Jupiter is essentially a giant musical instrument. Because the planet is so massive and made of fluid gases, it vibrates. These vibrations, called acoustic oscillations, are caused by the massive storms and internal heat rising from the core. Scientists have found that Jupiter rings like a bell, but with a complexity that reminds us of a Stradivarius violin. These songs of Jupiter allow scientists to peek inside the planet without ever touching it. By measuring how sound waves travel through its layers, we can map the depths of its metallic hydrogen sea. It is a world that is constantly humming, a low-frequency broadcast that ripples through the vacuum of space. As we pull away from the Jovian system, we realize why the ancients named it after the king of the gods. It is a place of absolute power of lethal radiation, moon-sized magnets, and volcanic moons that paint the sky in sulfur. It is the guardian of the inner solar system, a massive humming sentry that keeps the rest of us safe. At the center of everything, holding the entire system in a delicate gravitational embrace, is the sun. It is easy to think of the sun as a static ball of fire, but in reality, it is a living, breathing, and incredibly loud star. If sound could travel through the vacuum of space, the sun would be a deafening, continuous roar about as loud as a rock concert speakers held directly against your ear everywhere in the solar system. But the sun doesn't just roar. It sings. Using a science called helioseismology, we've discovered that the sun is constantly vibrating. Imagine the sun as a giant bell made of plasma. These vibrations are caused by the movement of hot gases rising and falling in the convective zone. These waves bounce around the interior, making the sun's surface move in and out. By listening to these frequencies, we can see inside the sun, mapping its core where temperatures reach 27 million degrees Fahrenheit hot enough for hydrogen atoms to smash together and create the very energy that keeps you alive. Perhaps the most fascinating thing about our star is its memory. Every 11 years, the sun undergoes a total transformation. Its magnetic poles actually flip. The North Pole becomes the South Pole, and vice versa. This cycle dictates the weather of the solar system. During a solar maximum, the sun is covered in dark sunspots, cool patches where magnetic fields are twisted tight. When these fields snap, they release solar flares with the power of millions of nuclear bombs, sending solar winds screaming toward the planets. It is a cycle that has repeated for billions of years, a heartbeat that pulse reads the life of our solar system. While the sun's internal vibrations provide a song for scientists to study, there is another, more ancient story written in the light itself. When you feel the warmth of the sun on your skin, you are touching something incredibly old. The photons, particles of light that reach Earth in just over 8 minutes actually began their journey in the sun's core tens of thousands or even hundreds of thousands of years ago. In the dense heart of the sun, light doesn't travel in a straight line. It is constantly absorbed and re-emitted by the thick plasma, bouncing around in a random walk. A single photon might take 100,000 years just to reach the sun's surface. This means the sunlight we see today was actually born during the last ice age on Earth. It is a slow-motion miracle that eventually breaks free into the vacuum of space at the speed of light. But like all stars, our sun is not immortal. It has a finite lifetime. Currently, it converts about 4 million tons of its own mass into energy every single second. While this loss is tiny compared to its total size, it cannot last forever. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core. When that happens, the sun will begin its final transformation. It will swell into a red giant, expanding so much that it will likely engulf the inner planets, including Earth. After this violent expansion, it will shed its outer layers into a beautiful glowing shell of gas called a planetary nebula. All that will remain is the core, a tiny, dense, Earth-sized remnant known as a white dwarf. This glowing ember will no longer produce energy, but will slowly cool over trillions of years until it eventually fades into the darkness. As we look at the sun, we see the engine of our existence. It is a massive humming sacrifice, burning through its own heart to light our way. It reminds us that our entire solar system is a temporary arrangement, a beautiful, fragile dance around a star that is slowly, quietly playing its final notes. As we pull away from the warmth of the sun and the familiar paths of the 8 classical planets, we enter a vast, dark frontier where the rules of the inner solar system no longer apply. This is the realm of the Kuiper Belt, a massive ring of icy objects that stretches billions of miles beyond Neptune. The Kuiper Belt is not a collection of stars or planets, but a frozen archive of the very materials that built our world billions of years ago. It is home to thousands of frozen bodies, including well-known dwarf planets like Pluto, Eris, Haumea, and Makemake. Some of these worlds are surprisingly bright. For instance, Eris reflects nearly all the sunlight that hits it, gleaming like a cold mirror in the absolute dark. But the true edge of the sun's reach lies even further out, so far that light itself takes months to get there. This is the Oort cloud. While it has never been directly observed, scientists believe this shell of trillions of icy fragments encircles the entire solar system like a distant, ghostly halo. It is the birthplace of long-period comets, those lonely travelers that occasionally fall toward the sun after drifting in the darkness for millions of years. The Oort cloud marks the end of our sun's gravitational influence, stretching nearly a light-year into the interstellar void. In this silent expanse, humanity has sent only a few ambassadors. The Voyager 1 and 2 spacecraft, launched in the 1970s, have spent over 40 years racing away from Earth at speeds exceeding 37,000 miles per hour. They have crossed the orbits of every planet and passed through the Kuiper Belt, finally crossing into interstellar space, the region between the stars. These probes carry more than just scientific instruments. They carry a golden record filled with the sounds, music, and languages of Earth, a message in a bottle for anyone who might find them in the distant future. As they drift further into the dark, they remind us that the solar system isn't just a collection of rocks and gas, but a small island in a vast cosmic ocean. Our journey through the solar system has shown us worlds of acid rain, diamond storms, and hidden oceans. We have seen how fragile and rare our own blue marble is, protected by magnetic shields and stabilized by a massive moon. But most of all, we have seen that the universe is far more active, musical, and mysterious than we ever imagined. As the last traces of starlight fade, we leave the solar system behind, knowing that there is still so much more to discover. For now, the story of our home in the stars continues in the quiet, endless dark.